So now that we've learned a little bit about the unit circle, and we've put some bits and pieces on it over the past couple of days, let's try to fill in a complete unit circle. And what you see right now is the first quadrant of the unit circle. So we started with 0 degrees, then we put in 30 degrees and 45 degrees and 60 degrees and 90 degrees. And in fact, what you probably did, based on the triangles that we worked with in our last set of notes, is that you filled in the ordered pairs first. But now, what I'd like to take a look at is, well, what about the rest of the circle? And the thing about the rest of the circle is, if you know this first quadrant, you can figure out the entire unit circle from this, at least the ordered pairs, and I hope more. And if we think of it in terms of symmetrical purposes, in other words, if we fold this circle hot dog style, so that the right side of the circle lands on top of the left of the circle, what happens is this first point that I'm going to fill in is going to have values of 1/2 and radical 3 over 2. The only difference is now we're in the second quadrant. And in the second quadrant, we have to go to the left with our triangle, and then we go up, which means that 1/2 is negative. And remember, we folded this circle hot dog style, and when we did, the green point is going to land right here with the same results. Instead of radical 2 over 2, comma, radical 2 over 2, it's going to be negative radical 2 over 2, positive radical 2 over 2. The first value in the ordered pair is negative, the second value is positive. Same thing with the red. When we fold it hot dog style, we're going to get radical 3 over 2 and 1/2. That lands right here. But because we're in the second quadrant now, that value is negative. It even works for the quadrantals. If you look at the very beginning, we started with that point 1, 0. So if we fold it over, the 1, 0 is going to land here. But now we went to the left, so it's negative 1, 0. We can also take that same kind of idea and we can fold the circle hamburger style. So we're going to fold it along the x-axis so that the top of the circle, top half of the circle, lands on the bottom half of the circle. And when we do that, we're still going to have this point radical 3, 2, and 1/2. But now, not only is the radical 3 over 2 negative, because we went to the left, but we're also going downward. Think back to the triangles that you used in the last notes. So it's going to be negative radical 3 over 2, comma, negative 1/2. And the same thing, we've taken this top half of the circle and we've folded it over. So it's not going to be negative radical 2 over 2, radical 2 over 2. It's going to be negative radical 2 over 2, negative radical 2 over 2. Both signs in that third quadrant are negative. Again, we're still using symmetry, so when we fold this over, our point here isn't going to be negative 1/2 radical 3 over 2. It's going to be negative 1/2 negative radical 3 over 2. And like I said, the quadrantals still work. 0, 1 is going to become 0, negative 1. If we stick with that hamburger style fold, again the top half of the circle landing on the bottom half of the circle, again what's going to happen is we're going to end up with not 1/2 radical 3 over 2, but we're going to end up with 1/2 comma negative radical 3 over 2. We went to the right, which is a positive direction, but we went downward, which is why that second value is going to be negative. Same thing here. Not radical 2 over 2, radical 2 over 2, we need to put a sign in, and it's going to be the second value. It's going to be negative. Again, I'm folding the top of the circle over and landing on the bottom half of the circle. So our red point would land right here. And the only change that we need to make is that the 1/2 is negative. Let's put in the degrees now. And we've talked about the degrees. On my circle, I think that the top lines are for degrees and the bottom lines are for radians, and on your circle the bottom lines are for degrees and the top are for radians. I think you can see that with respect to your picture. But as we take a look at this here, remember that these are all going together. Let me just fix something up here. I want to make that an order pair and make this an order pair and this an order pair. Ooh. As well as, I did that for the blue down here, the green and the red. Just make it a little bit better. I'm sure you're fine on yours, and I might have to move this over just a little bit so we can fit it in. But when we look at this here, the nice part is we've already talked about the fact that this is 120 degrees. And this is 135 degrees. And this one is 150 degrees. And then we've completed half of the circle. It's 180 degrees. But when you take a look at this, the thing also to notice here is that all of the red values are going together. They all work together. In fact, the reference angle for 150 degrees is 30 degrees. So when I go to my red value, the negative radical 3 over 2, comma, negative 1/2, in our third quadrant, what I'm doing is that ordered pair has a reference angle of 30 degrees, so I'm adding 180 degrees plus 30 degrees to get 210 degrees. And for the square root of 2 over 2, square root of 2 over 2, the 135 has a reference angle of 45 degrees. So down here in the third quadrant, this green point is also going to have a reference angle of 45 degrees, and 180 degrees plus 45 degrees is 225 degrees. And the blue ordered pair, 1/2, comma, radical 3 over 2, has a reference angle of 60. 120 has a reference angle of 60. So when we get down here to the third quadrant, we're going to take 60 degrees and we're going to add it to 180 to get 240 degrees. And over here, this is 3/4 of a circle, 270 degrees. And then we can follow through with this pattern one more time. Again, what's written in blue refers back to 60 degrees. To find my angle here in the fourth quadrant, I'm going to take 360 to minus 60 and get 300 degrees. And the radical 2 over 2 point, radical 2 over 2, negative radical 2 over 2, let me say it a little bit more precisely, has a reference angle of 45 degrees. And 360 degrees minus 45 degrees is 315 degrees. Radical 3 over 2, comma, negative 1/2 has a reference angle of 30 degrees. And 360 degrees minus 30 degrees is 330 degrees. And when we come full circle here, in fact, I think I'm going to move this 0. Whoops, erased everything, but move the 0 here and make that 360. And our point is still, remember, unit circle has a radius of 1. It's going to be 1, 0, right there. And we filled that in before, so hopefully that is starting to come together for you a little bit. And now what we're going to do is we're going to fill in radian values on here. And when we start, 0 degrees, 0 radians. Well, where some of these are coming from is that 30 degrees, we can convert it. And remember, when we convert so that we've got radians in there, we always use that calculation 30 times pi over 180, which gives us pi over 6. And we've done that computation already. I'm just trying to pull that back into your memory. Or for 45, we do 45 times pi over 180, which gives us pi over 4. And we can do 60 times pi over 180, which is pi over 3. And I'm running out of space here, but we could do 90 times pi over 180, which is pi over 2. Now the thing is, I'm not going to write down all of the different computations. If you want to do each single one, you multiply by pi over 180, simplify the fraction, and you will get the radians. I'd like to show you a trick here that I use to help myself remember the unit circle. And that is that I start with the green values, the pi over 4, and I count, but I do have a pretty strong foundation for fractions. I understand the fractions, which helps me. But if I start with the green pi over 4, that's 1 pi over 4. When I get up here to 90, which is the radians is pi over 2, that's 2 pi over 4. But 2 pi over 4 reduces, it simplifies to be pi over 2. So when I get over here to 135 degrees, that's going to be 3 pi over 4. When I get down here to 180 degrees, that's 4 pi over 4, but 4 pi over 4 simplifies to be pi. And I want to put that in black, not green. And then I keep going. Down here at 225 is 5 pi over 4. When we get to 270, that is 6 pi over 4, but 6 pi over 4 reduces to 3 pi over 2. 315 is 7 pi over 4. And then 8 pi over 4 is back where we started with. 8 pi over 4 is 2 pi. It works the same way with the pi over 6s. Again, you have to have some basic knowledge of factoring, or of fractions, to be able to do that. But when I count, I'm starting with the red pi over 6. Red pi over 6. Pi over 3 is the same thing as 2 pi over 6. Pi over 2 is the same thing as 3 pi over 6. Over here then, I'm at the blue, 120. We did 1 pi over 6, 2 pi over 6, 3 pi over 6. 4 pi over 6 is the same thing as 2 pi over 3. 5 pi over 6. Pi is 6 pi over 6. 210 is 7 pi over 6. 240 is 8 pi over 6, which simplifies to be 4 pi over 3. 270, I lost my train of thought. 7 pi over 6, 8 pi over 6, 9 pi over 6, simplifies to be 3 pi over 2. 300 is 10 pi over 6, which is 5 pi over 3. And 330 is 11 pi over 6. And when we get to full circle, 12 pi over 6 simplifies to be 2 pi. So on your desk, you have a blank, a completely blank unit circle. It says, practice filling in the unit circle. until you can complete it in 5 minutes. So you're going to place the degree angle measure of each angle in the dashed blanks inside the circle, and the radian measure of each angle in the solid blanks inside the circle, and you're going to put the coordinates on there to help you remember the unit circle, which is going to be a foundation for 95% of the rest of the school year.